Hello everyone, welcome. We are studying sets chapter 1 of class 11th. In the previous section, we have studied sets, what are sets, and how we can represent sets in a roster form and a set builder form. Today, we will going to study about types of sets. So, let us observe this example. In this example, we have to find a set of all those natural numbers which are both even and odd. Can we have a number which is both even and odd? No. You may see that the set A is empty. Yes, this is a first type of a set, empty set. According to the definition states, empty set, a set which does not contain any element is called a null set, void set or an empty set. Let us take more examples on it. Some examples are, as you can see on the set B. B is a set which is consisting of all those numbers which are even prime number but greater than 2. We know that there is no even prime number which is greater than 2. They are all odd. Hence, the set B is an empty set. Let us take the next example, which is set C. C is the set of all those real numbers such that number x is greater than 1 as well as it is less than minus 1. We know we cannot have a number which is greater than 1 and less than minus 1 simultaneously. So, the set C is also an empty set. Now, the last set D. D is consisting of all those rational solutions of this equation y square minus 2 equal to 0. On solving it, you may see that the solution of this equation is y is equal to plus minus under root 2, which is giving an irrational solutions. So, again D becomes an empty set. Students, note that whenever we have to represent an empty set, we represent it with curly brackets with no element in it, that is showing emptiness, or with a symbol which is known as phi. Okay. Now, let us observe another example. See this example. How many elements are there in the set A? 1, 2 and 3. 3 elements. How many elements are there in the set C? Notice C is the set of all even numbers. They are 2, 4, 6, 8, 10 and so on. So, how many elements are there in C? Infinitely many. So, students, you must have got an insight what will be the next type of a set. Yes, the next type is on the basis of number of elements in a set. They are finite set and infinite set. So, definition states a set which is empty or consists of a definite number of elements is called a finite set, otherwise infinite. So, let us take some examples on it. Examples, first we have already taken, we know it is having 3 elements, it is a finite set. Let us take the second example, set B. B consisting of all the names of the month in a year beginning with letter M. How many month begins with letter M? March and May, 2 months. Yes, it is again consisting of a definite number. That means B is a finite set. So, let us take another example, set K. The set of all circles having center 0, 0. Yes, you may observe in this image that when we change the radius slightly, we always get a new circle which is centered at 0, 0. So, there are infinitely many circles centered at 0, 0. So, this set K is an infinite set. Now, the last example D, we have already seen that the set D is an empty set, and according to the definition, an empty set is a finite set. Set D is a finite set. So, let us take a question in which we have to state which of the following sets are finite and infinite. So, let us take the first set, which is set L, the set of lines which are parallel to the x-axis. You may see, if this is my Cartesian plane, where this is representing x-axis, then we can draw infinitely many lines parallel to x-axis. It can be anywhere above the x-axis or below the x-axis. So, the set L becomes infinite set. Now, set K, the set of prime numbers which are less than 16. Less than 16. So, let us first list all the numbers, prime numbers which are less than 16, which are 2, 3, 5, 7, 11 and 13. You may see definite number is there, 6 elements are there which are less than 16 and prime number. So, yes, the set K is a finite set. Now, set H, in set H it is consisting of all those natural numbers which are lying between 1 and 5.23. So, let us again list them. What are they? 2, 3, 4 and 5. 4 numbers are there. So, again, yes, H is a finite set. Now, set M, set of all points on a circumference of a circle, and we know on a circumference of a circle there are infinitely many points. So, set M becomes an infinite set. Set B, consisting of all those numbers which are multiple of 3. Yes, you may correlate it with the previous example, the set of all even natural numbers. They are infinite, they were multiple of 2. Similarly, what we can say, this set is representing all multiples of 3, which are 3, 6, 9, 12 and so on. So, this set B is an infinite set. Now, the second last set, which is A, the set of points common to any two parallel lines. We know when the two lines are parallel, is there any point common between the two? No. Since they are parallel, so no point will be there which is common. That means set A is an empty set, and yes, empty set is a finite set. Now, the last set G. G is a set consisting of all those letters which are vowel in the word set. Now, see, set is consisting of 3 letters S, E and T. How many vowels are there in it? 1, which is E. So, G having one element which is E, and it is a finite set. So, hope you have understood how you can categorize sets in finite and infinite set. Students, you may observe one more type from the last example, which is singleton set. Yes, you may see that a set having only one element is known as a singleton set. Example, we have already seen set G, as it is consisting of only one element which is E. Okay? Now, since we have studied about what are empty set, infinite set, finite set, singleton set. Question arises, when we can say two sets to be equal? So, let us take these examples and see whether these three sets are equal or not. So, first let us name them L1, this is L2 and L3. So, can I say that the set L1 is equal to L2? No, it is not, as L1 is containing 3 elements and L2 is containing 2 elements. Here the elements are represented by colored balls. So, L1 is not equal to L2 as they having different number of elements. So, can I say now L1 is equal to L3 as they are having same number of elements? Again you will say no. Why? You can see L1 is consisting white color ball and L3 is consisting black colored ball. L1 and L3 does not have same elements. So, when we can say the two sets are equal, let us see the definition. The definition states, two sets A and B are said to be equal if they have same elements, otherwise they are not equal. When the two sets are equal, we write it as A equal to B, and when they are not equal, we write A not equal to B. Let us take example number 1. In this example number 1, you may see that A is consisting of 4 elements, 2, 8, 6 and 1. B is also consisting of 4 elements, 8, 2, 6 and 1. Both sets are equal. Why? Because they are having same elements. You may notice the order is different, but in set order does not matter, that is why A is equal to B. Now example number 2, D is consisting of 4 elements 1, 2, 3 and 4. B is consisting of 3 elements. So, from here itself we can see both are consisting of different number of elements. So, B is not equal to D. Now, see the last example, example number 3. H is consisting of 4 elements 2, 8, 6, 1 and T is also consisting of 4 elements 8, 4, 6, 1, but they are not equal. Why? Because 2 is not there in T and element 4 is not present in H. So, they do not have same elements. Example number 3 states they are not equal. Students, you may observe when the two sets are equal in number, then the sets are said to be equivalent sets. So, from the 3, we can notice that the example number 3 is representing they are equivalent sets. Now, let us take one example or a question in which we have to select sets in column B which are equal to the sets in column A. You may notice that these are the set in column A and column B. So, let us first study what type of sets are there in column A. First, set A. A is a set which consisting of all those letters in the word sets. So, let us first simplify and write it in a roster form. It can be written as S, E and T. Okay? Now, set B. B is the set of all those natural numbers which satisfy this inequality x square minus 2x plus 1 less than 0. You may see x square minus 2x plus 1 is forming a perfect square, which I can write here x minus 1 whole square less than 0 b. Okay? And you may see that for no element x, this inequality satisfies. That is, if we put any value of x in this, the value of this expression will always be positive. Either it will be equal to 0 or it will be greater than 0, but it will never less than 0. So, this implies B is a empty set. So, we can write it as phi. D. D is the set of all smallest even prime number. Smallest even prime number is 2. So, D is a singleton set. Let us write it as 2. And E is given with some set of numbers which are 2, 8, 6, 10 and 4. So, here we have studied all the sets in column A. Now, let us study all the sets in column B, and then we will see whether which sets are equal. Column B, set L. It consists of all those positive even integers which is less than equal to 10. Students, notice even and positive integers. That means we are talking about even natural numbers which are less than equal to 10. So, let us list all the elements in it. We can see that it is 2, 4, 6, 8 and 10. Okay. Set M. M is the prime divisor of 16. We know the only prime divisor of 16 is 2. So, M becomes singleton set 2. N is the set of some letters which are S, E and T. P is the set of all those solutions of this equation x minus 1 equal to 0. And what kind of solution? Natural solutions. And we know on solving it that it is consisting of only one element which is 1. And Z is an empty set phi. So, students, we have studied all the sets in column A as well as all the sets in column B, and you may notice that the set A is equal to set N, set B is equal to set Z, set D is equal to set M, and set E is equal to set L. Hope you have understood when the two sets are equal. Students, observe this image. What do you see? If I say this is representing one set and this is representing the second set, L1 is consisting of 4 different colored balls: orange, blue, black and yellow. L2 is also consisting of colored balls, blue and orange. Can you find any relation between the two? Yes, you may find that each and every element of L2 is there in L1. That is, every member of L2 is also a member of L1. Such sets are said to be subsets. Okay? So, what is the definition of a subset? The definition states, a set A is said to be a subset of B if every element of A is also an element of B. Mathematically, we write like this: A is a subset of B. Notice this symbol. Here, this is the notation which states that A is a subset of B. Sometimes it is also said contained. Why? Because every element of A is contained in the set B. So, A is a subset of B if A belongs to A. That means, if I take any arbitrary element in A, then it implies that A is also a member of the set B. If A is not a subset of B, then the notation used is like this. Let us take some examples on it. Examples, you may see B is the set of all prime divisors of 12 and A is the set of divisors of 12. Can you write the all divisors of 12? Let us list them. They are 1, 12, 2, 6, 3 and 4. These are the divisors. And what are the prime divisors of 12? So, set B becomes 2, 3. And again, by the definition, what the definition of a subset says? Every element of B has to be the element of A, and yes, we can see 2 and 3 is also a member of A. So, B becomes the subset of A. Another example, we can see the set of vowels is a subset of the set of all letters in English alphabet. Hope you have understood what is a subset. Students, there are various real life examples of subsets as well. For example, the set of all students in class 11th is a subset of the set of all students in your school, or the set of all children in your family is a subset of the set of all members in your family. Find more such examples and let us quickly recapitulate what we have done in this session. Today, we have studied about empty set, a set which does not contain any element, singleton set, a set having one element, finite set, a set having definite number of elements, infinite set, which the set which are not finite set, or we can say the set which does not have finite elements, equal sets, a set which have exactly same elements, and lastly subsets. A is a subset of B if every element of A is also an element of B. So, students, in the upcoming session, we will continue with subsets and study about power sets and universal sets. Thank you.